Here we go with our recording. Okay, so today what we're going to do is continue our look at number, right? We started off looking at numbers by talking about factors, talking about the counting numbers, talking about how to find factors, etc. Now today what we're going to do is we're going to continue with more things about specific numbers. Now before we do that, what we want to do is I want to talk about some of those rules for divisibility. Now you already know some of them, but some of them may be a little less familiar to you. So let's talk about those. They're really the extension, but they're really going to help you out here. So we'll first talk about rules for divisibility. Now what we mean is, how can I tell if one number will divide evenly into another number? And there are certain rules for it. Well, first of all, we know that 1 divides evenly into everything, right? But we also, most of us, know that we can divide any number by 2 as long as that number is even, right? So 4, 6, 8, any even number will also divide by 2. Well, if 2 has a rule and follows a pattern, then other numbers do as well. And so what we're going to do is we're going to look at a few of those. We're not going to look at a ton of them, but we're going to look at the most useful ones. For 3 is an easy one. If the sum of the digits is divisible by 3. I want to leave a little room over here for some examples. So let me see what we're talking about. So 12, we all know that 12 divides by 3, right? So, but if you look at it using the rule, the digits are 1 and 2. Well, 1 plus 2 is 3. And does 3 divide evenly by 3? Yes. Say yes. Turn on your microphones. Okay. Remember, this is participation. I still need to know that you're there. Okay. That means that 12 will divide by 3 as well. So, and you can do that with any number. So 1 plus 2 is 4. Does 4 divide by 3? Say no. Okay. Well, then neither will 112. Even though most people would look at 112 and think, yeah, that probably divides by 3, but it doesn't. 1, 1, 1. 1 plus 1 plus 1 equals 3. 3 divides by 3, so that tells me that 1, 1, 1 will too. Okay? Now, it doesn't do the division for you, but it does tell you if a number will indeed divide by 3. Okay? How does that look? So, let's move on. The number 4. Well, 4 is a lot like 2, isn't it? It's an even number. 2. It's just 2 2s. So the same rule has to apply. It has to be even, okay? And the last 2 digits must divide by 4. Okay? So we're not talking about sum. We're just looking at the last 2 digits. So look at this number, 112. Is 112 an even number? Yes. And what are the last 2 digits? They make the number 12. Will 12 divide by 4? Yes. Then so will that whole number. Okay? You're just looking at 2 digits because 4 is 2 2s, right? Okay. 5 is an easy one. We use this one all the time. If it ends in 5 or 0, then it's divisible by 5, right? So 15 is divisible by 5. 250 is divisible by 5. Again, it doesn't do the division for you, but it does tell you. Okay. 6. Think about how you would make a 6 by multiplying. What 2 numbers would you multiply together to get 6?
3 times 2.
You bet. So, if it's even and divides by 3. it will also divide by 6. So do you see that if you have a bigger number, it's usually just the combination of the of the rules for the two smaller numbers. Okay? Now 7 has a rule, but it's more complicated than it's worth. Just divide. 8 is 2 and 4, right? It's 3 2s. So 8 is the same rule as 4. I'm not going to write it down because you're not going to use it very often. But 8 is the same rule as 4, but it's not the last 2 digits that divide by it. It's the last 3, which makes it harder to use than it's worth. Okay? 9 is a good one, though. You'll use 9 a lot. And 9 is just like 3. If the sum of the digits is divisible by 9. So have you seen these before, guys?
Yes.
Okay.
Seen some of them.
So like 36. 36 is 3 plus 6, which is 9. 9 divides by 9, so that means 36 will as well. Okay. The ones you're going to use the most are 2, 3, and 5. Those are the big ones that you really should memorize. But the other ones are helpful. And they'll at least, they won't tell you how to do the division, but it will at least tell you that you can do the division. Which should tell you that the stuff we're going to do today all involves division. You bet. Your favorite, everybody's favorite. Okay? All right, good job. So keep those in mind as we move forward. And we're going to talk about, we're building the number system. And again, this is mostly review for most of you. The first thing we're going to talk about are what are called prime and composite numbers. Now, I'm going to write on here. I'm not going to rewrite these as notes. But a prime number is a natural number that has exactly 2 distinct factors, one in itself. So for example, 3 is a prime number because the only factors of 3 are 1 and 3. Okay? Remember, 1 is a factor of everything. So can anybody tell me, so look at the prime numbers up to 20 here, if you look at this at your notes. 2 is a prime number because 2 can only be written as 1 times 2. 2 is the only prime number that's even because if it's any other bigger even number, then it'll divide by 2, right? So 2 is the only prime number that's even. 3 is prime, 5 is prime, 7 is prime, 11 is prime. So that gives you the idea that it's every odd number, but that's not true because if you look at 15, 15 is not prime. So prime and odd are not the same. Okay? So exactly 2 factors, I'm sorry. A composite number simply is any number that has more than 2 factors. In other words, it's usually easier just to think of composite as any number that's not prime. So if it's not prime, then it has to be composite. Okay? Except for the number 1. 1 is a special case. It's not prime or composite. 1 is a special case, so make sure that you know that 1 is not prime or composite. 1 is a special case. It doesn't fit either one of those categories. But every other number fits one of those categories. Sounds good?
Yep.
Okay. All right. So you have some notes as well. So write 32 as a power of a prime number. Okay? To do factors by prime, that she's showing you here in the notes using prime factors using a factor tree. And you can use the factor tree if you want. It's a perfectly acceptable method. I think it's messy, and I don't really like it as well. Instead, I use another method for finding factors, and I'm just going to show it to you. Now, does that mean I'm telling you have to use my way? No. I'm just telling you that I'm going to give you an alternative way. What I'm going to show you is upside down division. And the reason I like it is because it keeps things organized and we can use it for a lot of different things. The first one we're going to look at is to factor into primes. Okay? If you're going to factor something into primes, that means the only numbers I want to divide by are prime numbers. Okay? So first, put your number in an upside down division symbol. And I know this sounds weird, but all it does is it just keeps you more organized. Okay? So let's say we're doing, what was that? 32 was the one that they were doing, right? Okay? So all I did was put my number in my upside down division symbol. Okay, second, I'm simply going to divide by primes, and I'm going to continue until I get a prime. And by prime, I mean prime number, right? And you always start with the smallest prime number possible, which is always what number? What's the smallest prime number, guys?
2.
2, you bet. Okay, so we'll try with 2. Will 32 divide by 2?
Yes.
Yes, 32 divided by 2 is 16. Is 16 prime?
No.
No, that means I can divide again. And 16 will divide by 2. 16 divided by 2 goes into 2. 2 goes into it 8 times. Is 8 prime?
No.
Nope. So that means I can divide again, and it'll divide by 2, which gives me 4. 4 is not prime, so it'll divide again by 2, which gives me 2. Is 2 prime?
Yes.
Yes. So do you see that I just continued to divide until the number that I got here on the bottom was a prime number. And now I'm just going to write it as multiplication. And all the numbers that you need to multiply, all the prime factors, are the things on the outside. So using the upside down division symbol kept the other stuff inside, separated from your answer. Okay? So it's 2 times 2 times 2 times 2 times 2, right? 1, 2, 3, 4, 5 of them, which can be written as 2 to what power?
5.
The fifth power, 2 to 5. Okay? Now, again, the factor tree works perfectly fine, but what happens is students are messy. I know none of you are messy, right? But students are messy and get unorganized. So if you do it with the factor tree, what you're doing is you're doing the same exact work. But see, if you got to here with this was on there, then you would start writing up and down on the side of the page and sideways and next and on another page and everywhere else. Ugh, makes me crazy. So the only difference here, the method is the same. This method just keeps you organized. It also allows you to do more than one number at a time, which is something that we'll see later. Okay? So
Is it just to find like multiples of a number?
Factors. Right? Not multiples. Factors. Things that divide it into it. Okay? So, and again, you don't have to do it this way. You can use the factor tree. The factor tree is the old traditional method. I guarantee that you probably will not see very many teachers showing you this. It's a very unusual method, but I like it, and I'm going to use it a lot. I don't like the factor tree, but if you use a factor tree, would I count it wrong?
No.
Absolutely not. Don't ever let anybody tell you you have to do it my way. That's just not the way life works, yeah? But give it a shot, because I think you might surprise yourself about how organized it is. And also, we can expand it and use it for different things. Like I said, we can do 2 or 3 numbers at a time. Whereas a factor tree, if you were doing 3 numbers, you'd have to do 3 different factor trees. Okay? And I'll show you what I mean by that later as we get into problems. All right? So factoring numbers into primes. So let's see, what's the next example there? She has 264. So let's look at it. So we want to factor 264 into primes. Again, we know 2 will go into it. Doing the long division, that gives us 132. 132 is even, so we know 2 will divide into it again. So what is that? Goes in there, 5, which gives you, I'm sorry, nope, 6. I can't divide, huh? 2 won't go into 1, but 2 goes into 13 6 times, which gives you 12 left over, so another 6, so 66. 2 will go into that 33 times. Will 2 divide into 33?
No.
No, because it's not even, right? Okay. But 3 will go into it. How many times?
11 times.
And is 11 prime?
Yes.
Yes. So that's where we stop. So 2 times 2 times 2 times 3 times 11. And the 2's repeat. So that part we could write as 2 to the 3rd power. The other numbers don't repeat, so we can't write them as an exponent. But the numbers that do repeat, we have 3 2's multiplied together, so that's the same as 2 to the 3rd power. And so there's our completed answer. Okay? So it works with any process. Now again, you don't have to use that. You can see that she did it here with the factor tree just fine. No, did I divide wrong? No, 4 and 11. No, okay. So you see that jumping around the numbers? 2 there, and then a 3 there, and an 11 there, and a 2 there, and a 2 there. I don't like it. It's messy. I like to start with 2 and use 2 as long as you can, then try 3, then try 4, etc. I'm not 4, obviously. 5 or whatever primes. Okay? All right? So it technically doesn't matter as long as they're correct, but do them in order. Numbers are put in order because they need to be in order. Okay? Is that all she has for us? How nice is she being? So let's look at the task just to make sure. So this is task 3. Task 2 is using those rules for divisibility. So let's just give that a quick glance. And again, this is an extension task. It's not bad for you to know, but you are not required to know that. Well, it's not going to come up. Sorry, pictures sometimes take a bit to go. Determine whether the following numbers are divisible by 2, 3, 4, 5, and 6. So those are the only ones you want to worry about. So let's see. Is 43 divisible by 2? No, because it's not what? Even, right?
No, I think you have to add a digit in.
Oh, okay. Find blank if the following are divisible by 2. Let's see.
Like you had to put like a 2 in, like to make it divisible. Like you could do 2, 4, 6, or 8 or something like that.
I don't like that. Let's see. Okay, so what number could you put in there to make it divisible? Okay, I get it. So you could put in a 0, a 2, any even number, right, would make that divisible by 2. Okay, any even number would make that divisible by 2. And here, you could put any number 1 through 9, because 6 is at the end, it's already divisible by 2. What about this one? Could you put any number in that box to make it divisible by 2?
No.
Be careful. You couldn't because the 3 at the end is not divisible by 2. Okay? All right. So just using your rules for divisibility, and she didn't use 9. This doesn't use 9. It just uses 2, 3, 4, 5, and 6. Right? So let's look at C. Is C divisible by 2? Yes, because it ends in 6, right? Sorry, I'm pointing with my mouse, but y'all can't see my mouse pointer, can you? So it ends in 6, so it is divisible by 2. Okay? We need to see if it's divisible by 3, and to do that, I just add up all the digits. 8 and 2 are 10. plus 1 more is 11, plus 6 is 17. Is 17 divisible by 3?
No.
Nope. Then neither is that number. Then we want to try 4. The last two digits are 16. Is 16 divisible by 4? Where my voice went.
Yes.
So so is that number. Then we want to try 5. Is the number divisible by 5? It ends in 5 or 0. Does it end in 5 or 0?
No.
So not 5. Then we need to try 6. Well, remember, all we need to do is look on our list. It's divisible by 6 only if it's divisible by 2 and what other number?
3.
2 and 3. Is 3 on our list?
No.
No, so it's not divisible by 6. Okay? So just go through and find the rules for divisibility. And again, that one's an extension task, so you can do it if you want to, but you don't have to. Right? What you do have to do, though, is task 3. Okay?
Yay.
Yay. Okay. All right. And the first thing they do is they give you some powers, some exponents, and then ask you to work those out. We didn't do those, but that should be a review task, hopefully, for you. Let's just make it a little bit bigger so that I can just do that. Remember that if you have the power, then the base and the exponent, it doesn't tell you to multiply 2 times 3. That's 2 times itself. How many times?
3 times.
3 times. So 2 times 2 is 4, times another 2 is
8.
8. Okay? So this one, is that being 2 times 4? Nope.
8 times.
2 times 2, 4 times. Okay?
16.
Exactly. Now, guys, when you're doing that, let me just show you, because it's easy to get confused about that, so I'm coming back to do this. So if I'm doing 2 to the 4th power, here's what I do. 2 times 2, it's 2 of them, is 4, right? Times another one is 8, times another one is 16. So that means I've used up all 4 of them, right? Or you could make a tally if you want to, but be careful. It's so easy to get confused and not put enough numbers or forget where you are, right? So do some little trick or something to remind you how to do it. Let me go back to sharing real quick so we can look at some of the others. Look at G, for example. In G, we have several numbers raised to powers. We have 2 to the 2nd, which means 2 times itself. So 2 times itself makes 4, right? Times a plain old 3, so that doesn't change. Times 7 to the 2nd means 7 times what?
7.
Which is?
7. 49.
49. And then you would just multiply those 3 numbers together to get your completed answer. Okay? All right. Okay, so let's see. Find using your calculator. Number 2 is optional. You can do number 2 if you want to. That's fine. Number 3, I do want you to do list all the primes less than 30. Number 4, write the following as powers of primes. So in other words, find all the prime factors. And then here, express the following as a product of prime factors in index form. Remember, index is just another word for an exponent or power. Index, exponent, power. So, prime factors, that's using that, either the factor tree, if you stay focused and organized, or using the other set, the other method, the upside down division symbol. Okay? Then she gives you some extension work below. This is just about powers. And again, you can attempt the extension work if you want to. It's just building on what we've already done. So you're more than welcome to do it, but you don't have to. Okay? So anytime it says extension, that means optional, right? So some of you will want to, some of you may not. Okay? So, how's it look, guys?
Good.
Good. So, what we're going to do today is our actual lesson is Term 2, Week 1, Lesson 3. So Lesson 3 is the one that you have to do, right? And of course, not the extension part of it, but just the Lesson 3 part of it. And then you can do Lesson 2 if you want to. Again, that's an extension. I would be happy if you did, because learning those rules for divisibility are really important. But you're going to use them when you're doing the other sets as well. Okay. Yeah. Okay. How do you feel?
Good.
All excited? You have some weekend
Good.
fun to
Happy.
do now, since you have math
Yes.
homework on the weekend. You love that, right?
Also, it's not like we can do anything on the weekend.
Okay.
Yeah, we literally can't.
No, it's
School
bad
is
and
pretty
good.
much-
It's like kind of like I can control your whole lives. It's nice, right? No. Okay. No.
When is this homework due? Like next lesson or?
I'd like for you to try to get it. They're short lessons, right? So and they're short so that you can try to get it done by the next time we meet. But if you don't, it's not the end of the world. Okay? So try to get them done by the next time we meet. That's why we're keeping them very, very short. Okay? But if you don't, like I said, don't worry, don't panic too much. Do not get behind more than one lesson, though, because it's really going to start hurting you. Because, as you can see from what we did today, it was kind of built on what we did last time. So make sure that you realize they're going to build on each other. So don't get too far behind. This good? Everybody happy?
Yes.
Ready to watch your video? Have you gotten your video link yet for the assembly?
Oh, are we still doing assembly?
I haven't seen a video link either. So I got the message that she was going to do a video for us, but I haven't gotten a link for it either. I don't know. So maybe there
Well, we
won't
have
be.
to go to form time, and I think we're having form time today.
Are you having form
I'm not
time?
sure.
I'm not having form. I had form time with mine on Wednesday, and I'm only doing form time on Mondays for my class. But of course, I'm not your form teacher, so
I think we're probably going to do it Friday.
yeah,
Aw.
yeah.
Yeah, we get a link via email, because that's what happened last time, but I didn't actually get to watch it all.
Yeah.
It's optional,
they'll
though. You don't have to actually
so they'll
watch
send
it.
you a link.
Oh, yeah.
Yeah. All right. What other classes y'all got today? Some fun stuff.
Drama. We have drama. Then we have assembly, and then we have Spanish, and then we have English.
Oh, cool.
I've got English, and then
I love
assembly,
doing drama
French, then
at home. It's so fun.
Yeah.
How do you do drama?
Well, we do it's not like we don't do practical activities, but it just talks about like conventions or whatever.
Ah.
And then last time we played drama games, sort of we had to get up to 10, but if and like counting, but if someone said the same number at the same time, we went back to 0.
Oh,
So
that did not.
that was hard online
I
because
bet.
everyone just talked over each other, but it was fun.
Cool. That would be hard. At least math. I don't have to. I don't have to do anything different than I do in class for math for y'all. But I would be stuck if I had to do some other topic. English would be okay.
Yeah.
English would be okay, I guess. But
The sort of sit-down subjects aren't bad, but stuff like science, it's not like you can do science experiments at home. You can't really do a drama performance at home or a PE routine. I mean, you can do PE. We're doing parkour at home, but
You could do drama, by a video call, you do a performance in a space.
yeah.
But if you're doing it with a partner,
Parkour at home, is that kind of like just jumping on the bed?
It would sort of be fun to do Romeo and Juliet, except on video call. So everyone emailed the lines, and then you just all said it. That would be really fun.
That'd be very fun.
But at least you have math. That's easier to.
Right. We're
teach
focused.
online.
We're the team, the easy team. Exactly. All right, guys. Well, then you have your assignment, and it's almost interval time, so I'm going to let you get. And I will see you then next week. Does anybody know what day we meet?
No.
We meet on
Monday, period 5.
Okay. Oh, period 5. Okay.
Yeah,
Cool
I'll see
beans.
you next
So we'll
Monday.
see you next. So I'll see you on Monday then.
Yeah.
Excellent. Have a great weekend. Great to see you.
Bye, Mr. Sal.
All right.
Thank you.
Bye.
Bye.
Bye.